Alright, so we're going to focus on this word today, discriminant. I'm going to explain what it means. Real easy to find. And so when I give you the worksheet today, instead of solving everything out, you're just going to find the discriminant first. Okay? And we're going to talk about what it means. Okay? Who remembers what this word means, quadratic? Good.
It means 4, quad.
Well, I know quad usually means 4, but you're right. It's a power of 2. So if it has an x squared in it, that means it's quadratic. So, you don't necessarily have to write this down because we already talked about it, but a quadratic equation contains an equal sign. That's what equation means. And it has the highest exponent of 2. You might want to write that down. So if it has an x cubed, it's not a quadratic. That's a cubic. But notice it's got to be an equation, and it has to have highest power of 2 in order to have a discriminant. If that's true, then it has a discriminant, and we're going to find the discriminant and talk about, what it means. But I'll go ahead and allude to that. A discriminant is going to determine how many solutions you have. And there are 3 possibilities. No solution, that's possible. 1 solution, or 2 solutions. That's it. There's only 3 possibilities. The discriminant will tell you which is which. All right. So let's talk about when you can find a discriminant and when you cannot. So the first example I'm giving here, 2x plus 3 equals 7. There is no discriminant because it's not quadratic. The highest power is 1. Okay, let's look at some more examples. So x squared plus 4 equals 7x. That is quadratic. That would have a discriminant. The third example, notice the highest power is 4. That's not quadratic, so therefore it would not have a discriminant. And so you might be thinking, well, why do we need to know how many solutions it is? Why not just solve it out? Well, sometimes it's easier to figure out if it has no solutions. Why go through all the steps just to figure that out? If you know the discriminant is a certain thing, meaning negative for that example. If the discriminant's negative, it has no solutions, it saves you a lot of time from solving the whole thing out. That's why we do this. All right, does anybody remember the quadratic formula? Because I'm about to show it to you. Down. This is the quadratic formula. Later on, I'm going to show you a proof for this. You can get extra credit for me if you can do the proof by yourself. And I've had a lot of students before say I could never do that, and they ended up doing it. And I have some examples on the wall over there in case you want to take a look. In fact, I have a proof over there that's very close to the quadratic formula. You can look at it later. I don't want to hear any overreactions here, okay? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just going to go ahead and simplify this for you today. We are only going to be focusing today on this part. So all you need to know today is b squared minus 4ac. And I'll talk about where a, b, and c come from as well. But what I've just outlined here is the discriminant. Okay? And it's going to tell you how many solutions your equation has, your quadratic equation. The discriminant is what's inside the radical, which I outlined. So it's b squared minus 4ac is the discriminant. Let's see if I can. So, whoops, that right there. All right. So here are the three scenarios for the discriminant. This is the most important thing. First one. So whenever the discriminant, so what's inside that radical, b squared minus 4ac, is bigger than 0, meaning it's positive, you're going to have 2 solutions. So again, when I give you the worksheet today, you're going to find out what the discriminant is. If it's positive, you'll write 2 solutions, and you'll be done for today. So let's say we figured out b squared minus 4ac, we figure out a, b, and c, we plug it in, and we get 10 back, or whatever. As long as it's positive, we can write the equation has two solutions. That quadratic equation has two separate solutions.
Is that after the 4AC, is it one of those like greater than?
Right. Yep, that means greater than.
Oh, I didn't know.
All right, the second scenario is if the discriminant is equal to 0. That means it has one solution. So if you figure out a, b, and c, you plug it in and you get 0 back, that means your quadratic equation has one solution. X squared minus 6x minus 9 would be an example. Not that that really means anything to you, but once you solve that out, you just get x equals 3, I think, and you only have one solution. And the third scenario is obviously if it's negative. So it's either positive, it's equal to 0, or it's negative. If your discriminant is negative, you will not have any solutions. And once you write that down, I'm going to explain why that is. So the reason why this is true, let's go back and look at the formula. So we have a square root here, right? And this says plus or minus. So if this is positive, right? This is positive, then we're going to have plus whatever that radical is and minus whatever the radical is. And so putting that together, that's going to give us two different answers for x, which is why when we have a positive discriminant, we have two solutions. Now, if this is 0, then we get plus or minus the square root of 0, which is always 0, right? So really, our solution is just going to be negative b over 2a. That's only one solution. Now, if it's negative, we have a problem because we have the square root of a negative number. It doesn't exist, right? Because the square root of a negative number doesn't exist, that will mean we have no solutions for our equation. So that's where it comes from. Let's look at the first example. It says determine the number of solutions for this quadratic equation. And we have 3x squared minus 7 equals 4x. So now we're going to learn about a, b, and c. What do those actually mean? Actually, you already know. You already know because we've used the x method, right? It's the same a, b, and c as the x method. Once you get everything on one side, it'll be the same thing.
So we're still subtracting the 4x?
Yes, very good. You're still going to move everything to the left, get everything on one side, so we will subtract 4x and move it to the left. But the thing is, it has to be in order. Yeah, so put the x squared term first, put the x term next, and the constant term last. And now you can see what a, b, and c is based on, if you know how to do the x method. Here's your a, 3. Your b is negative 4. Your c is negative 7, same as the x method. So next you're going to write out a, b, and c for step 3. Again, a is going to be 3, b is negative 4, c is negative 7. It's going to look like that. Is to find the discriminant by plugging it into that formula, b squared minus 4ac. So notice we are plugging in negative 4 for b right here. We are plugging in 3 for a. We are plugging in negative 7 for c. And then simplifying it out. So negative 4 squared is 16. And then 4 times 3 times 7, 84. But it's two negatives. That's important. That happens a lot. When you're subtracting something that ends up being negative, two negatives make a positive. So it becomes 16 plus 84, which is 100. So we figured out that the discriminant is positive. What does that mean?
Two solutions.
Good. It's going to have two solutions. And that's all you have to do for today's lesson. You don't have to figure out what x actually is. But since you know what the discriminant is, it's going to help you solve it even quicker because all you have to do now is plug 100 into the square root and simplify that. We have negative 2x squared minus 4 equals x, for example 2. You can already see kind of what we're doing for step 1. We have to move that x to the left. And remember, when you move it, make sure you order in descending power, so it'll wind up being negative 2x squared minus x to the first minus 4. So who can tell me from there what a, b, and c is going to be? B is not negative x, sorry.
Negative 1.
Negative 1, yes.
And
Close.
C is
C is negative 4. That's correct. Okay.
Hey, why is it not negative x? Oh,
It's the number next. It's the coefficient of x, not x itself. And since it's minus x, you got to put a negative 1 there. So that's why it's negative 1. Right? So there's the discriminant, b squared minus 4ac. I'm going to plug this stuff into it. So b is negative 1. We're going to plug it into. So notice I'm putting in parentheses, right? That's important. If you don't put it in parentheses, you get negative 1 back. But because it's in parentheses, it being squared, it becomes positive 1. And then plugging in negative 2 for A and negative 4 for the C. And so, look, this is 3 negatives. 3 negatives make it what? It's going to, yeah, still going to be negative. So it is 4 times 2 times 4, which is 32, but it's 3 negatives, so it remains subtracted. Negative 1 squared is 1, so you get 1 minus 32, which is negative 31. So discriminant means what for this problem? How many solutions? 0. Right. No solution. And so you can see with this example that once you've solved for the discriminant, you don't have to use the entire, you don't have to write out the entire quadratic formula. You can just literally put this has no solution and you're done with the problem. All right, last example. It's the example I was talking about earlier. X squared minus 6x equals negative 9. First thing you're going to do is add 9 to both sides to get it over here. So you get A equals 1, B equals negative 6, C equals 9. I will pause and let you get that copied. So we're going to plugging this into B squared minus 4AC. B is negative 6, so put negative 6 there. A is 1, C is 9. All right, so negative 6 squared is 36. Subtracting 4 times 1 times 9, 36, we get 0 back. So this equation has one solution because the discriminant equals 0. What I want to do is show you what the graph would look like for each of these examples. You don't have to write any of this down, but I think it'll help you understand the problem a little bit more. So the first example, we got 2 solutions back. What that would look like if you were to graph this is that the parabola is going to end up crossing twice. Okay? That's what it looks like. It's got 2 solutions. It will cross the x-axis twice. The next example we looked at, we got a negative discriminant. We said it's no solution. What that would look like, let's see. Okay, yeah. What that would look like is the parabola is not going to cross at all. So it doesn't have an x-intercept. It has no 0 solutions. Okay? And then the third thing we looked at had 1 solution. That's going to look like, actually, let me ask you guys, what do you think that one's going to look like? So what's going to
be like a diagonal line?
It's going to go like that. Okay, it'll barely, somewhere down here, anywhere along the x-axis, right, it'll cross once. It'll have 1 solution. So that's what it looks like on the graph. Parabolas. Okay, so all quadratics are a shape of parabola. All right, so I'm going to get you the worksheet now.